When we detect structures in the depths of space that shouldn't even exist on paper, who is wrong? The universe or our theories? For 2 years now, the James Webb Telescope has been using its infrared vision to explore the most distant and oldest structures in the cosmos. It has repeatedly shown us that the actual outgrowths of the universe are not particularly interested in our models, and that their mere existence plunges established cosmology into chaos. For example, the experts still cannot explain how, just a few 100 million years after the Big Bang, there could already have been galaxies as large and massive as our Milky Way today. And yet, this is by no means the only mystery that Webb has now added to the star maps. It has also shown us the unexpected blossoms that the planetary world of the universe can produce. Some things simply belong together, day and night, ebb and flow, or a planet and its host star. This is hardly surprising since all planetary worlds in our home system orbit the mighty Sun. And if we look beyond the cosmic horizon, we recognize that exoplanets are simply distinguished by the fact that they orbit a star other than the Sun. But did you know that there are also planets out there that break this fundamental pattern and instead make their journey through space without stellar assistance? These loner stars are known as rogue planets, and we are dealing here either with celestial bodies that were ejected from their original system after their formation or that were never gravitationally bound to a star in the first place. The latter are also known in specialist circles as sub-brown dwarfs, and their birth did not take place as usual in a protoplanetary disk but just as with stars or brown dwarfs, through the contraction of a stellar gas cloud. However, it's in the nature of things that such planetary loners are comparatively difficult to detect in the vast expanses of space. After all, they don't shine invisible light and hardly reflect starlight at all. And yet, with the help of infrared telescopes, it's possible to detect rogue planets, or candidates for them, based on their own heat emission. In fact, our previous investigation of our galactic neighborhood has shown us that rogue planets are by no means as rare as one might assume. In reality, they are abundant in our home galaxy. Specifically, astronomers now estimate that there are almost twice as many rogue planets as stars in the Milky Way. In other words, if our galaxy is home to an estimated 100 to 300 billion stars, it also has around 400 billion free-floating planets. And as we now know, there is one particular region that is home to a particularly large number of rogue planets, the Orion Nebula. What Webb has discovered in the Orion Nebula? In astronomical terms, the Orion Nebula is practically on our doorstep. And since the colossal cloud of interstellar gas is not only just 1,350 light-years away from us but also one of the most active star nurseries in our galactic neighborhood, it has become a popular object of study in the past decades of research. Experts estimate that around 2,800 young stars are dormant inside the Orion Nebula, and the immediate vicinity is also adorned with countless twinkling celestial bodies. But to literally shine a new light on the well-known, the James Webb Telescope pointed its near-infrared camera, NIRCam, at the stellar nursery a few months ago and captured 2 wide-angle mosaics of the Orion Nebula. These consist of more than 3,000 individual images, and they have revealed something that does not fit into the astronomical picture at all, namely, believe it or not, 40 free-flying planets in one fell swoop, which, as already mentioned, come without a mother star. Although rogue planets have been discovered in the Orion Nebula in the past, these representatives are particularly massive celestial bodies, so-called Jupiter mass binary objects, or, in short, jumbos. The fact that this discovery was met with surprise, to say the least, among researchers is primarily because the jumbos live up to their name ad absurdum, because it actually looks as if these loner planets in the Orion Nebula occur in pairs. So, what is the background to these unexpected constellations? Fortunately, researchers were able to uncover some basic characteristics of the jumbos immediately after the Webb images were taken. According to these, we are dealing with astronomical whippersnappers here who are just 1 million years old and have surface temperatures of around 1,000 degrees Celsius. But how did the jumbos end up in such large numbers and in pairs in the Orion Nebula? Why the jumbos are so mysterious? Well, we can only speculate about that at this point, and the same applies to the question of what these jumbos actually are. The first theory is based on the assumption that the jumbos were born in a region of the Orion Nebula that was too poor in matter to form real stars. Since there was not enough hydrogen available here for the formation of stars and the ignition of nuclear fusion, we could therefore be dealing with a column of failed stars. Alternatively, however, there is also the hypothesis that the jumbos initially grew in the normal way to become Jupiter-like gas giants and were ultimately literally expelled from their home system by an unknown event. Although the experts emphasize that they consider the expulsion theory to be the more likely one, they also admit that they do not know why the celestial bodies were separated from their mother stars in pairs. A clear explanation sounds different, but given the constellation of the giants, is it at all possible that we are dealing here with the result of a random event? After all, the fact that the celestial bodies always come in pairs is joined by the fact that they all have a comparable structure and mass. In view of this, some scientists point out that we should perhaps admit that our models for planet formation and evolution are probably anything but complete. In other words, the structure in the Orion Nebula could be based on a fundamental mechanism that is currently completely unknown to us. Who knows? Maybe the corresponding structure represents not only a diligent star producer but also a full-fledged jumbo factory. If the hydrogen density here is always distributed in certain regions in such a way that it can never produce a real star but always two gas planet-like objects that are gravitationally bound to each other, we would no longer speak of a coincidence but rather of a pattern. And although this approach may seem plausible, it's still awaiting official confirmation. What has now been officially confirmed, however, is the finding that the James Webb Telescope has detected a whole series of objects that have left experts scratching their heads. How Webb is pushing cosmology to its limits. As mentioned at the beginning, these include, above all, the impossible galaxies that already existed 500 to 700 million years after the Big Bang and which, despite this, already contained up to 100 billion solar masses of stars. The reason why these structures became known as universe breakers is that they are in sharp contradiction to current cosmology. According to our theories, there simply wasn't enough normal matter at such an early stage to form so many stars in such a short time. And just as with the jumbos, the question arises as to how complete our theoretical understanding of cosmic evolution is and how much it ultimately matches the real processes in the universe. No less confusing is the gigantic black hole that the James Webb Telescope identified in an equally very early galaxy. This was already present 770 million years after the Big Bang, and despite all this, a gravitational monster of over 1 billion solar masses slumbered at its center. Experts analyzed which feeding mechanism allowed the black hole to grow to such dimensions so early on, but they found nothing unusual. Instead, the object's background seems surprisingly normal, so that the cosmic mystery ultimately only deepens. In other words, the supermassive black hole was already fully mature when the cosmos was just 5% of its present age, and we have no explanation for this baffling growth spurt. And then there is also the problem of the so-called Hubble tension. In principle, the Hubble constant indicates the rate at which the universe is currently expanding. But strangely enough, past research had already revealed an inexplicable discrepancy. While the determination of the Hubble constant taking into account the cosmic background radiation is theoretically 67 km per second per megaparsec, the actual measured values turned out to be significantly higher. If we take red giants, supernovae, or the special type of star called Cepheus into account, we suddenly get a value of 73 km per second per megaparsec. So, was this a systematic measurement error in the past? Unfortunately not, because the observations of the James Webb Telescope have once again confirmed the Hubble tension. According to the experts, the faster expansion of the universe could be caused by a process or force that has not yet been taken into account in the cosmological standard model, for example, an exotic form of dark energy or dark matter. But it's also possible that we have misunderstood the true properties of gravity or that there are particles or fields out there that no researcher has yet heard of. And now comes a bold call to subscribe that you should have heard. We invite you to press the like and subscribe button so as to never miss another video from our channel again. We'll see you soon.